Hello, hope you guys can hear me. Let me just set up some things. I'm going to be learning C again this stream. It's going to be exactly like my last C stream. Hold on, it's lagging. I have VS Code open and I have a React app running, so that's why I think it's quite slow. Let me change to full screen. Okay, so from my last stream, you might remember my study notes website. And here are my notes so far. So far I worked till chapter 4. Where is zoom in? Zoom in more. Okay. So I was in this chapter, and for the VS Code, I had terminal open. Wait. Reveal this in File Explorer. Go here. Go to CMD. GCC first.c. I don't know why it's taking so long. And then I will run a 0, 1, 2, 3, 4, and then a is equal to 5, and I finished. So it's running this program basically. A is 0 first, and then 0, then it increases to 1. So 0, 1, 2, 3, 4, and then as soon as it's equal to 5, it goes out and then it says a is equal to 5, and I have finished. And then new line. Right. Next chapter. More flow control. The if statement and while loop described in the previous chapter are fairly simple control structures. In this chapter, we are going to look at a few more complex structures that can help to make your code shorter and reduce the amount of typing you need to do. Okay, so the first one is the for one. Although the while loop we saw in the previous article is very useful, the for loop tends to be favored by many programmers as it puts all the logic controlling the loop in one place. Here is an example. For loop example, and then okay. Copy text. So for starts with, this is the first initialization, and then it tests, and then if it fails, it runs the code here. So this is the first step. It's lagging right now. This is first, this is second, third is everything in between, then lastly it checks it. Sorry, lastly it does this, and then it checks again. Let me copy this, write it here. This isn't all that different from a while loop, but all the control for the loop lives in the round bracket after the for loop. This contains three statements separated by semicolons in order. These are the initial condition, the test, the increment. A is equal to 0 is the initial condition. The variable A is initialized to 0 at the start of the loop. A is less than 5 is the test, just like in a while loop. This is checked on each iteration of the loop, and the loop code is only executed if the test evaluates to true. As soon as the test is false, execution continues after the curly bracket at the end of the loop code. A++ is the increment. This is code which is executed at the end of each iteration of the loop before the test is evaluated again. In this case, it adds 1 to A. So when this for loop runs, what happens? First, A is set to 0. The test is then checked. Is A, which is 0 less than 5? Yes, it is. So the code inside the curly bracket is executed and the value of A is printed. Finally, the increment is applied, meaning 1 is added to A. The test is then repeated. If true, the loop code is executed again and the increment is again applied. This repeats over until the test is failed, at which point execution continues after the closing curly brackets. I should take this, add it here. First is set to 0. And then this is the new point. The output when the for loop runs is identical to that of the while loop in the previous chapter. They both do exactly the same thing. In terms of what they do, for loop and while loops are pretty much identical. You can initialize multiple variables in a for loop, just separate them by commas. So if you want to set two variables at the start of the loop, you can use this. Okay, switch statements. One thing that you quite often want to do is to test a variable against several values and do different things based on each of them. You can do this with a set of nested if statements. That does start to get pretty long-winded, though. So C provides a neater way of doing this called a switch statement. Okay, wait. Switch statement example. Switch A, then case 0, print F, break, case 1, copy this. This does exactly the same as the example above with the multiple if statements. Works like a multiple if statements. The uplink 9 consists of the keyword switch with the name of the variable in round brackets. Okay, this is the variable which will be tested against the various cases. The body of the switch statement is a number of case statements. The variable A is compared against each case in turn. If it matches the value immediately after the word case, then the lines of code after the semicolon are executed. The final case is just called default. Every switch case should include a default case as the final one in the list. And this is the code which is executed if none of the other cases matches. I'll just take this. Default. I'll copy this break statement stuff. Notice that the last line in each case section is the word break. This is very important. The keyword break tells the compiler that you want to break out of the switch statement at this point. That is to stop executing code inside the switch and to resume execution after the closing curly bracket. If you forget to include the break statement, every case after the one you wanted will execute as well as the one you wanted. Okay. Keyword break out. All three types of loops in C, while, do, while, and for can be used pretty much any situation where a loop is needed. Choose whichever you like. Some people prefer to use one type of loop for everything. Others pick and choose whichever looks tidiest for each circumstance. Leaving a loop early. The break statement has one other use. It can be used inside while and for loops to break out of them. See, I'll write the example in here. Why doesn't it break the line? This. So while one break printf so it will keep incrementing unless a is 5 where it will break out of the loop. So we have a while loop in which the test is just the value 1. This is a non-zero value and so is always true. If you enclose code inside curly brackets after while one statement, the loop will never end. It will keep running forever. But in this case, we have provided an alternative way to end the loop. We test the value of a inside the loop itself in an if statement. And if a is equal to 5, we call break. This causes the loop to end and execution to continue with the statement after the loop. A break statement like this can be useful to leave inside a loop early in the event of an error, for example. Okay, let me copy this. After while true, I will put this in code. In the case above, we test the value of a inside the loop itself in an if statement, and if a we call break, this causes the loop to end and execution to continue with the statement after the loop. The keyword continue can be used in the loop instead of break, but instead of breaking out of the loop, it skips all the rest of the code in the current iteration, turns to the test case. I'll do this. Pointers. Okay, this part can get confusing for me. The term pointer has struck fear into the heart of many beginner C programmer. But once you have got your head around them, pointers are a very useful feature of a language. They aren't actually that complicated in reality, but it's easy to get confused when using them. So let's try to avoid that. Remember, when we looked at the declaration of variables, declaring a variable, telling the compiler what type it is and what it is called before you can use it is necessary in C, because the declaration enables the compiler to allocate a block of memory to store the variable. So every variable you declare, there's a block of memory which is set aside by the compiler for that variable, and the compiler remembers which particular block of memory is used for each variable. What is a pointer? A pointer is just an address of a block of memory with a variable in it. That's all there is to it. So if you declare a variable and a pointer to that variable, you can access the value in that block of memory in two ways, either the variable name or with the pointer. Let's take a look at this simple example. I'll break this up. And let's copy the other statements. This. So let's see what it's doing. So A, pointer to A, pointer to A is equal to this. Then A is 5. Value of A is this. Let me run this. What? Oh, I need to save it. So the value of A is 5. Then the value is 6. Because the value in the pointer changes. The value of pointer to A is this. It stores the value 6. The address of A is this. Okay. Slash 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 slash. Taking it line by line. The first line is one we have already familiar with. We are already familiar with. We declare an integer variable called a. But what's this? This looks like it's declaring another integer variable, doesn't it? But look more carefully. The asterisk at the start of the variable name indicates that this is not declaring an integer variable, but a pointer to an integer variable. Look at the line. This. So we now have an integer variable called a, and we have a pointer to an integer variable called pointer to a, but neither of these actually has a value in it, yet they are both initialized. It's all very well calling the pointer to a, but it has no idea what or where a is, so we will fix that with the next line. With this line. Fix there. Pointer to a has no idea what or where a is, so we fix that with the next line. This is the important bit. In C, the symbol ampersand before a variable means address of the variable. So address of a means the address of a in memory to the address in memory of variable a. I'll type this. And the and symbol. Okay. The next level lines are familiar. We will set a to 5 and just to check that worked, we print its value. So let's try doing the same thing but with pointers. So pointer to a is 6, or at least what's stored in pointer to a. The asterisk again was used in slightly different way from before. When declaring a variable, putting an asterisk before its name indicates that the variable is a pointer, but once the pointer exists, putting an asterisk in front of its name means the variable pointed to by this pointer. Okay. This is known as dereferencing the pointer. Uh, so this line tells the compiler to set the variable pointed to by the pointer to a to 6. So the line we know that the variable pointed to by pointed to a is a. We set that up a couple of lines back. So this line is just another way of setting a to 6. Indeed, if we print the value of a, we find it has changed to 6. The next lines will hopefully help you get the relationship between pointers, variables, and addresses clear in your mind. In this line, we are printing the value of pointer to a, not the value it's pointing at, but the value of the pointer itself. This prints a very large number as it's the address in memory where a can be found. In this line, we are printing the value pointed to a, not the asterisk before the name. This prints the value of a. Finally, in this line, we are printing the address of a itself, not the ampersand sign before the name. Again, this prints a very large number, the same as the value of pointed to a we printed before. Uh, in the line, no, not this, in the line, we are printing the value of pointed to a, not the value it's pointing at, but the value of the pointer itself. This is the same as ampersand a. Now copy this in the line. We are printing the value pointed to A. Note the asterisk before the name. This prints the value of A. When I was first learning about pointers, I found it helpful to say out loud what a line of code was doing. An asterisk is what is pointed to by, and ampersand is the address of. Once you've got those two ideas fixed in your head, you have pretty much understood pointers. The crucial thing to remember when working with pointers is this: you can't just declare a pointer, as you need to also declare and associate the variable you want it to point to. When a pointer is created, it creates a random location in memory. If you try to write something to it, you can cause all sorts of errors, up to and including crashing the computer completely. Always make sure pointers are pointing at something before doing anything with them. Pointers are one of the ways C allows, or in some case forces, you to think about what the actual hardware of the computer is doing. A good understanding of pointer gives you a good understanding of how a compiler handles a memory. Always have something to point to. It's worth stressing this again. A pointer is not a piece of memory, it's just an address of memory. Okay, avoid pointers and casting. You can also define a pointer without saying what type of variable it's pointing to. This is called a void pointer, written as void asterisk. If you think, wait, hold on. If I go back here, int, okay. If you think about it, this makes sense. A pointer is just an address in memory, so we don't necessarily need to know what is at that memory. To use a void pointer, you need to cast it. Casting is telling the compiler how to interpret what is at the memory location pointed to by a pointer. You tell the compiler what sort of variable it should expect to find there. Here's an example. My computer is lagging. Should I reload? So it's doing int and then char. This is gonna get confusing. Okay. To page. Also, the page number is like this. I think the show cover page is different. I think this is the correct way. Okay. Anyways. zoom, zoom. Uh, it's taking so much time to load. This and sorry, wait. Let me understand what's happening here. This C here. Can also define, hold on. Go ahead. A white pointer. We initialize the void pointer to point an integer variable called int value. Called int value in the first printf statement. We insert the first printf statement for default. Okay, wait. This cast void pointer to an integer pointer, so the value of int value is printed as an integer. Wait, hold on. Okay. In the second printf statement, we insert char pointer in front of void pointer before we dereference it. This calls a void pointer to a char pointer. Okay, let's run it and see what we get. Uh, 11. Hold on. ACII. Sorry, I'm just searching something up in Google. Okay, wait. Okay, I'm looking at the ASCII. If I do this, mod 120s. What is this? How do I do a mod of? If I can do that, I'll just do it here and see. Percentage 127. Or 120. Let's do 256. Let's do mod value. Mod value is 11. What's the range of char? Is it from positive 0 to positive 256? The last printf gives 11 because this mod 256 is equal to 11. class on explanation. Wait. Chart type C range. Or 0 to 255. What do you use pointers for? That's really all there is to pointers, other than to ask why bother. We can already access a variable with its name, so why do we need to have some complicated alternative way of getting the contents of a variable? There are several ways in which pointers are useful, which we will explore in more detail in later chapters, but a few important ones are function calls. In the next chapter, we will look at how to split up C code into functions, string handling, and arrays. Okay, so asterisk a plus plus increments the value pointed to by a, but asterisk a plus plus increments the pointer itself rather than. Okay. Okay, next chapter, functions. Functions. Up until now, all the examples we have looked at have had one single function, main. We have already seen functions used. The main function is a standard C function, albeit with a special name. We have already seen the printf function called by our examples. So how do we create and use a function of our own? Here is an example. Example of our own function. This This includes both main function and a second function called sum. In both cases, the structure of the function is the same, a line defining the value returned by the function. The function name and the function arguments followed by a block of code enclosed within curly brackets. This is what function actually does. Function can have any number of arguments from 0 up to 100. If you don't need any arguments, you list the arguments as void in the function definition. Okay, let's copy this. Function has 3 parts. Can do this. Append the first part, like this this property over here. Make sure that the list is opened by default. I'll show you in just a minute. Hold on. The first part is the type of the value returned by the function, in this case an int. So finally, within round brackets are the arguments to the function, separated by commas, and each given its type, in this case 2 integer arguments a and b. Int result. Okay. This declares a local variable for the function, and integer called result. This is a variable which can only be used locally within the function itself. Variables declared within a function definition can only be used within that function. You can read or write res within the main. If you try to read or write res within the main function, you will get an error. You can declare another int called res within the main function. This would be a different variable called res within the sum variable, and would get very confusing, so it's not recommended. and sum. This result should be, okay, res is equal to a plus b. This result should be obvious. Note that a and b are two defined arguments of the function. When a function is called, a local copy of the argument is made and used within the function. If you change the values of a and b within the function, that only affects the values of a and b within this function. It doesn't change the value that the arguments had in the function from which it is called. Okay. Note that a and b the value of a and b. Finally, we need to return the result. The function was defined to return an integer, so it must call the return statement with an integer value. Function doesn't have a return value. If the return type is set to void, it returns nothing. There's no need for a return statement in a function with a void return type. The function will return when it reaches the last line. However, if you want to return early, in the event of an error, you will just call return with no value after it. This so it must be called return statement with an integer value. We declare a variable within a function. It's only usable within that function, not within any function which call the function, or within functions called by the function. But if you declare a variable within a function, it's only usable within that function. Okay. Not within any function which call the function. Not within any functions which call the function. Okay. Okay, I understand. Or within functions called by the function. Okay. Alright. Think I should write this as well. B. Okay, calling a function. Let's look at how we call the function from main. It go up. Okay, it's lagging so much. The sum function returns an integer, so we set an integer variable equal to it. The arguments we supply to the function are inside the round brackets in the same order as in the function definition. So in this case, a is 5 and b is the value of y. Can you return more than one result from a function? You can only return one value, but you can also use pointers to pass multiple items of data back to the calling function. Consider the example. So over here they have this extra thing. They're passing the result variable. We modify the sum function to calculate both the sum and the difference of the arguments. The sum is returned as before, but we are also passing the difference back using a pointer. Remember that the argument to a function are only local variables. Even if you change one in the function, it has no effect on the value passed by the calling function. This is why pointers are useful. By passing a pointer, the function doesn't change the value of the pointer itself, but it can change the value in the variable to which it's pointing. So we call the function with the same two arguments as before, but we have the third one, a pointer to the variable where we want to write the difference calculated by the function. In the function, we have this line. Okay, let me just copy this. All this. A minus B in sum do I have it correct? Let's see if it runs. Nope. Sum and difference. Nope. What's the issue here? Is it this? Yeah. The sum is this. The difference is this. Good. See. Returning. Never mind. We have modified the function, sum function to calculate both the sum and difference of the argument. Let me add this next example. The sum is returned as before, but we are also passing the difference back using a pointer. Remember that the arguments to a function are local variables. Even if you change one in the function, it has no effect on the value passed by the calling function. This is why pointers are useful. Okay, that this. By passing a pointer, the function doesn't change the value of the pointer itself, but it can change the value in the variable to which it's pointing. So we call the function with the same two arguments as before, but we add a third one, a pointer to the variable where we want to write the difference calculated by the function. In the function, we have this line. The difference is written to the variable to which res is a pointer. Uh, In the main function, we call the sum and difference function like this. We provide the address to the integer diff as a pointer argument to the sum and diff function. When the difference is calculated, it's written into the variable diff in the main function. Okay. Let it load. Okay, it's loading again. Uh, all right. A function can return a single value or no value at all. If you define the function as returning void, there's no need to use a return statement in it. We'll get an error if you don't include a return of the correct type in a non-void function. Arguments are local variables within a function. If you want to use a function to modify the argument you give it, make each argument you want to modify a pointer to a variable. You can then read the value pointed to within the function and write the changed value back to the same pointer. One thing to bear in mind when defining functions is that the compiler reads files from top to bottom. You will need to tell it about a function before you can use it. Okay. But in larger files, when multiple functions call multiple other functions, this gets complicated. It's not always easy to make sure the function definitions are all in the right order. To avoid this, C allows you to declare functions before you have used them. Example. Wait. Nope, never mind. Um, okay. Next chapter, arrays and strings. Arrays and strings. The variables we have looked at so far are all single numeric values. In this chapter, we are going to look at how C handles list of values that leads into using list of letters to store and manipulate text strings. An array in a is a single variable which stores multiple different values at the same time. The individual values are accessed by indexing the array. An array can have one or more dimensions. A one-dimensional array is a single list of value. Okay. Copy this. An array is declared in C by putting the size of each dimension in square brackets after the variable name. So A10 is a list of 10 integers, while 56, B56 is a list of 5 lists, each of which contains 6 integers. When accessing the elements inside an array, the array index, the number inside the bracket, starts at 0. So the 10 integers contained within the array above are referenced to as A0, A1, A2, and so on up to A9. The compiler will quite happily allow you to read A10, A11, but these are outside the memory which was allocated when the array was declared. So writing to them is a really bad idea. And then array A A0, A1, this brings up to the relationship between pointers and arrays. The name of an array is effectively a pointer to the first element of the array. Remember that a pointer is the address of a variable in memory, while an array is a contiguous block of memory which contains all the elements of the array in order. So you can use a pointer to access it. In fact, even if you use values in square brackets to access it, the compiler treats those as pointer anyway. Here's an example. Uh, oops. Okay, copy this. Let's see if it works. So we are initializing an array and then this variable count, and then we are running this 10 times. Also we are storing count times 10 plus count. The first and second elements of A are 0 and 11. So it would be like 1, 1, 2, 2, 3, 3, 4, 4, like that, I guess. Or as pointers. Okay. Hold on. Okay. This fills the 10 values of A with the numbers 0, 1, 1, 2, 2, 3, 3, and so on. Then reads A0, A1. It reads the same value using A as a pointer. Copy. Then paste. No, copy, paste. Array elements are stored sequentially in memory, with the array name being a pointer to the first element. Multidimensional array elements are stored with the elements with neighboring values in the rightmost index next to each other. Okay. You can initialize an array at the same time you declare it by putting the values in curly brackets. Okay. By putting it in curly brackets. But note that this only works when the array is first declared. Once it exists, you can't use the shortcut. And we'll need to iterate through the array indices, setting each value in turn. Okay, looking back at this, getting confused by this. So the memory address. Wait, hold on. A is a pointer. So let's do this. Oh, percentage D. And then let's do A plus 1. Why is it doing this? Shouldn't A plus 1 be 4, 1, like 2, 4, 1? If I do int, no, float, float B10, and then I do this, what do I get? Also for, it happens if I do size, size, hmm. Yeah, hold on. Why is it like that? Why is it? Oh, it's because it's negative, I guess. Oh, size of B is 40 because it's 4 times 10. I should do size of B1. And this is 4. Size of one element is 4. So it skips 4. Huh. Um. Let's do long. And let's see now. Size is still 4. What happens if I do long, long? Size is 8. Now it's skipping 8. What if I do double? Size is 8. Is there such thing as long double? or 16. Why does a plus 1 skip like the size of the element? So a plus 1 is like the next memory block, but plus 1 is like, it should be doing memory number, the address plus 1, right? What is that? Wait. I don't know. This is dereferencing it. Because I would be thinking it should be plus size of the type. One of the nastiest sources of crashes and bugs on C is creating an array and then writing past the end of it. Compiler won't stop you writing to memory of the an array, and doing so can have serious consequences. Always make sure your array indexes fit inside your array. Remember that the name of an array or a string is just a pointer to the first element of the array or string in question. Okay. In C, a string is another array. It's an array of single characters. I can't see my mouse. So a string with 10 characters would be, a character is a specific type in C called char. This holds a single byte, which is enough to hold an alphanumeric character. Right. Is this correct? Or minimum size? Because when I did size of B or size of B1, it said 4, like 4 bytes. When it was integer, it said 4 bytes. This was 4, so it should be one byte is 8-bit, right? So int is 32 bits. What is this A? Let's try jar. Jar. Ah, 8 bits. 1 byte. A character, a culture. So a string. One important thing to remember is that a string in C must always end with a byte set to 0, and that the memory required to hold this final 0, called a string terminator, must be allocated when you declare the string. So my string, which is declared as an array of 10 characters, can actually hold 9 or fewer characters. Uh, okay. Sorry, my laptop is really slow. Strings are stored as an array of single characters with the element after the last character set to 0. You can use the index and square bracket to access individual characters in a string, or you can use a pointer. Here is an example of using pointers to join two strings together. First, second, and then 3. Destination is equal to source. Source plus plus destination plus plus. And then source is equal to string 2. Wait. Oh, I see. So first source is string 1 and then it's string 2. Okay. Isn't there a way to automatically prettify the code? I will do that later. While this is 0, Then for a second, okay, it works. Here is an example, joining two strings together. First, we create two strings. Okay, I think I get the idea. Because writing two strings, because the name of the string variable is only a pointer to the first character of the string, you can't just use an equal sign to set the value of a complete string. You can initialize a string variable at the time you declare it as above, but what if you want to set or change it later? There are few ways to do this. The most useful is sprintf function. This is a version of the printf function we have already seen, which writes arbitrary text to string variables. The only difference is that the first argument it takes is the name of the string of a string variable, and it writes to that instead of to the terminal. Okay, so what's the value here? So it writes this to this. Hmm. So the value is 12 char 50 as printf string value, and then printf. Let's see if this works. What a value of val is. Oh, it's like printf, but the string over here gets stored here. Okay. Uh, Whoops. Always remember that the memory you allocate for a string needs to be long enough to hold all the characters plus one extra to store the terminating 0. If you're manipulating strings yourself with pointers, make sure you remember to write the 0 at the end of any string you create. In the next chapter, we will look at some of the functions provided in C's string handling library to make working with strings easier. Chapter 8, the string library. Okay, should I do this next stream? Computer is really slow. Before I do go there, want to know why pointers adding no, incrementing pointers goes to next element. I want to know why the memory address value doesn't become +1. Guess I'll end the stream here. In next stream, I might continue studying this or might do some language learning. I'll see. Okay then.